right, we're moving towards our discussion of the second purpose for using z-scores, transforming entire distributions. But in order to do that effectively, we need to stop and talk about three characteristics of the z-score. It's already been implied, if not outright kind of stated in earlier parts of this chapter, but we're going to make them explicit here. So if we transform everything, so we have a whole distribution of z-scores, one of the things that is of note is dealing with the shape of that distribution. If you take a whole set of raw scores and turn them into z-scores, the shape of the distribution does not change. Recall I mentioned earlier that if I take a raw score and turn it into a z-score, I haven't made the score better or worse, higher or lower. Examples I used, I didn't make the temperature higher or lower. I didn't make the length longer or shorter. I just converted from centimeters to inches or from Fahrenheit to centigrade. So if the shape of the distribution was a nice normal bell curve, like we saw in the previous examples of raw scores, when I turn them all into z-scores, it'll have the exact same shape. If it was positively skewed before, when I convert it all into z-scores, it will have the exact same positive skew. We're not moving anybody's scores. We're just converting them to a different scale. So if it was negatively skewed before, the shape will remain negatively skewed. The shape does not change just by converting raw scores to z-scores. Secondly, the mean for our distribution of z-scores will always equal 0. If we think about it, remember, what is a z-score? It says how far away from the mean are you as measured in units of standard deviations. Well, if you're at the mean, you are 0 standard deviations from the mean. And lastly, the standard deviation. What will that be? The standard deviation for z-scores will always equal 1. Now, all the way back at the top of this chapter, I said that a z-score is a type of a standard score with a predetermined mean and standard deviation. So that's the definition really for a z-score, is that it has a mean of 0 and a standard deviation of 1. So whatever the raw scores were, we've got the same shape, but the mean is now 0 and the standard deviations are counting by ones. Remember, standard deviations have to be positive. By having negatives here, it's just telling us it's on the left side, that it's below the mean, but the distance is always positive. So this will always be true. Any set of raw scores you have, you convert them into z-scores, you're going to have a mean of 0, you're going to have a standard deviation of 1. That's how they're built. And the shape remains unchanged. All right, so let's take this into a more specific example. So let's say that you have a couple of classes and you've had an exam in each class. And what you'd like to know is, well, in which class did I do better? So let's say you've got a psychology class and you've got we'll say a biology class. Well, in the psych class, you took a test and you got a raw score of 60 points. In the biology class, you took a test and you got a raw score of 55 points. Well, which class did you do better in? Just like we said at the top of this lecture, there's no way of telling. We don't know what these scores really are. Are they typical scores, high scores, low scores? We don't have any means of evaluating them on their own. And so not only can we not understand one on its own, but we can't really make any meaningful comparisons between the two. So we need some more information. So let's say we learned that in the psych exam, that exam had a mean of 50 points and a standard deviation of 6. Let's say for the bio exam, the mean was 52 points and that the standard deviation was 4. Well, what we want to do is convert these into z-scores so we can make that comparison. So let's go ahead and convert these raw scores into z-scores. So your raw score minus the mean divided by standard deviation. So for psych, raw score 60 minus the mean 50 divided by standard deviation of 6. Once we round that, we see that our z-score is 1.67. So we're basically 1 2/3 of a standard deviation above the mean. So we know that's a fairly high performance. It's above the average range, right? Doing the same thing on the biology side. Raw score is 55 minus the mean of 52 divided by the standard deviation of 4. So when we do that math, and again, I encourage you to pause and do the math and see how you did, we get a z-score equivalent of positive 0.75. So in the biology class, you were 1 2/3 of a standard deviation above the mean, above that range of scores that we're calling common or average. In biology, you're only less than 1 standard deviation above the mean. You're right basically in the middle of the pack with everybody else. It looks like you did better on the psych exam than you did on the bio exam. That basically is what it amounts to conceptually when we're talking about the second objective, converting raw scores into z-scores. We could do this for every person in the classroom, right? And we'd know that the mean for our z's would be 0 and standard deviations are 1. But this is rarely where we stop in the real world. There are a couple of problems with z-scores. These are social problems. These aren't academic or mathematical problems, if you will. These are kind of social issue problems. One of them is that these scores are small. Z-scores we're counting by ones, and so, your family had you do on your psych exam, and you said, I did great, I got a 1.67. You and I know now that means that you scored pretty well. You were almost 2 standard deviations above the mean. That's well above the average range. But it doesn't sound all that impressive. You scored less than 2. It doesn't sound great, right? Let alone imagine if you were below the mean. That's the other problem here is socially we don't much like to think about negative numbers, particularly in describing ourselves. If I said you took an IQ test and your IQ score as reported in Z's was negative 0.50, that sounds really bad, right? I mean, just socially, you have a negative IQ. Well, remember what that would mean. A negative 0.50 means you're a half standard deviation below the mean, which means you're average, you're typical. Your performance was common. Below the mean, but in the common range. So we don't much like to work with z-scores because we just sort of find them, I don't know, distasteful maybe is the word for it. We don't like the little numbers. We don't like to having any negative scores, right? So what we usually do is we'll take a distribution of raw scores and we'll convert them into z-scores, much like we've done here. And then we're going to take those z-scores and usually convert it to a whole nother scale yet. So that it's at a scale that socially we like, with nice big numbers and everything's going to be positive. So let's say that I want to take all of this and I want to convert it again. I've already taken the raw scores and convert them into z-scores, but now I'm going to convert them to a whole new scale because I don't want to mess with z-scores. So predetermined mean and standard deviation. We get to pick, So I'm going to pick a mean of 100. So for our new distribution, I want a mean of 100, and I want a standard deviation of 10. Why? Because those are nice, easy, comfortable numbers to work with. We all can count by tens. It's an easy thing. So what I need to do then is take the raw score, turn it into a z-score, and now take that z-score and turn it into basically a new raw score on a new scale. So I want to know if this is the scale I'm working with for what's your raw score on your psychology exam? I'm just putting a little P on there. Remember, a subscript is just like a label or a tag. It just tells you what it belongs to. So your raw score from the psychology class, what would that be? Well, we want to get a new a raw score from the scale, so we should use the raw score version of the formula. Right? So we want to know what the score is. That's what we're trying to figure out. The new mean is going to be 100. The z that we're working with here was positive 1.67. And the new standard deviation is 10. So now we just use your algebra chops, 1.67 times 10, and then add that to 100. And you should find that this new raw score is 116.70. Now, a raw score in the original distribution of 60 points converted to a z-score of 1.67, converted to a new raw score on a new scale of 116.70. It didn't change this person's performance. It didn't make them score higher or lower. It simply relabeled it. So let's continue thinking about this in the next clip and take it a little more graphical.